My name is Emily Stark. I'm a software engineer on the Google Chrome security team. And what I want to tell you about today is a whole grab bag of projects that we're working on, work that's designed to make the entire web HTTPS, and not just HTTPS, but high quality, strong, shiny HTTPS, so that users get the best security that HTTPS has to offer. I'm going to be talking about kind of a grab bag of projects. Stick with me, there is an overall theme. So I want to start by, talking about this message of HTTPS everywhere. We hear it a lot these days. It's something that there are a lot of projects pushing for. Modern browsers are moving in this direction. We've been hearing HTTPS everywhere for years from the EFF, who distributes this browser extension that sort of advances the idea that the web should be HTTPS by default. And insecure HTTP should really just be the exception. It should be what you fall back on when HTTPS isn't available. So from all the way back, HTTPS Everywhere, which has been around forever, there are also a bunch of newer projects like Let's Encrypt. This has gotten a lot of buzz, but in case you're not familiar, Let's Encrypt is a new CA, a certificate authority, that is offering free automated certificates. And so one of the motivations for Let's Encrypt is that setting up HTTPS should be so easy that any mom and pop shop can do it, and so every website on the web should really be HTTPS enabled. And HTTPS Everywhere is also something that, as I mentioned, modern browsers are pushing for. This is a screenshot of Chrome in a slightly experimental configuration. And there's two things I want to highlight here, two ways in which, in this screenshot, Chrome is evangelizing HTTPS Everywhere. So the first thing I want to highlight is this deprecation message in the console. So what we have here is an insecure HTTP site that is trying to access a powerful web platform feature, which is the geolocation API. And this console message is saying, hey, in the future, Chrome isn't going to allow this because geolocation is too powerful a thing to fall into the hands of any network attacker. It should be something that is only available to the site that the user actually thinks they're visiting. And that's why we're deprecating the usage of powerful web platform features over insecure HTTP. So this is a gradual effort. We're not, trying not to pull the rug out from anyone, but we are starting with this deprecation message to warn developers that if you want to use the full power of the web these days, you really should be using HTTPS. And the second thing I want to highlight on the screenshot is this experimental configuration. So I'm running Chrome right now with a field trial flag, which you can actually turn on in your own copy of Chrome. And this field trial flag is experimentally marking insecure HTTP pages as negative. So you can see it's not that neutral page indicator icon that we are used to seeing on insecure HTTP. It's like an actually negative bad state. And this is something we want to do in the future, gradually start marking insecure HTTP as bad instead of neutral, because HTTPS should be the norm and insecure HTTP should be the exception, where users notice it and say, hey, something's wrong. This is not the state that I expect the web to be in. So those are some examples of how modern browsers, and Chrome is not alone in these efforts, all modern browsers are sort of making the move towards HTTPS everywhere. What I want to ask in this talk is whether HTTPS everywhere is actually the right thing for us all to be chanting. And you can probably guess by the fact that I have this question up here, the answer I think is no. It's not even good, in fact, for every site to go turn on HTTPS if it's not well configured and if it's not high quality HTTPS. So to make this point, this is a great example. This is the error page that Chrome shows when a site has failed certificate validation. So when Chrome can't set up a valid HTTPS connection because the certificate chain failed to validate. And our data shows that Chrome displays this error page hundreds of millions of times per month. And there's no way that's all actual attacks. And there's no way that's even actual server misconfigurations. This is just a whole bunch of cruft that's happening on clients and networks and servers that's causing users to see all these hundreds of millions of false positive errors every month. And this is really bad because we don't want sites to go turn on HTTPS and then this is the web that users see. If that's what happens, then users will be trained to ignore these warnings. They'll be trained to try to click through them, and they won't think that they won't be able to reliably interpret these in the case of an actual attack. And it's just a bad user experience. You know, these users trying to go to this website to get something done, they can't access the site. They don't. The average user can't be expected to know what's going on, to know how this might influence their behavior on this site. So overall, it's just bad for websites and bad for users if we turn on HTTPS on a bunch of sites, and this is the result. Another example of where HTTPS can kind of go wrong like this is this UI. This is another piece of Chrome UI. And this is what you see when you click on the lock icon on an HTTPS page where Chrome was able to set up the HTTPS connection and validate the certificate chain, but subsequently noticed some other problems with the page. And the thing here is that this is confusing and wordy. If you're an average end user looking at this, you probably don't know what it actually means or how it affects you. Anecdotally, even the average developer doesn't have a great time trying to figure out what's going wrong here. So this is another example of something that can go wrong when a site turns on HTTPS, and a state that we don't want the web to end up in. So what I'm going to be talking about in this grab bag of projects that we're working on in Chrome is what we're doing to get not just HTTPS everywhere, but high quality HTTPS everywhere, where the users have a good experience, they don't get confused by scary UI, they are actually getting the security and privacy benefits that HTTPS can give them. I'm going to divide this into 3 sections, just so you know where I'm going with this. First, I'm going to talk about what we are doing to understand the problem from the client's point of view, because I mentioned there's a whole lot of messiness in clients and networks in addition to servers that is causing HTTPS deployments to kind of go wrong. And so I'm going to talk about a data set we're gathering that is helping us understand what is going on in the wild. Then I'm going to talk about some web platform tools we're doing. So once a website has kind of set up HTTPS, and once a user has actually been able to connect to the site over HTTPS, we're working on a set of tools in the web platform itself to help the developer migrate the application to HTTPS. And finally, we're asking a lot of developers when we ask them all to go to HTTPS, and so I'm going to give you a sneak peek of some tools we're building in Chrome to just help developers understand this landscape, because as easy as we try to make it for them, it's a complicated landscape that we're trying to make it easier for them to understand. So I'll start here with what we're doing to understand the problems from the client's point of view and understand what's going wrong that's making HTTPS not as good a user experience as it should be. I want to go back to this SSL error page that Chrome shows when it fails to validate a certificate chain. About maybe 8 or 9 months ago, you might have noticed this addition to the HTTPS error page. This is a checkbox that we added that allows the user to opt in to send us a report about what's going wrong. Because our hypothesis was that the hundreds of millions of these that we show every month cannot be all actual attacks. They cannot all be actual kind of accidental server misconfigurations. There's other things going wrong on the clients or the networks that are causing us to show so many of these every month. So I want to talk about some of the patterns that have emerged from this data set we've been collecting and analyzing, telling us what's going wrong in the wild for clients that are seeing certificate validation errors. The first pattern that emerges overwhelmingly is that client clocks are really, really bad. So this just like sticks out so much. 30% of the time that Chrome shows a certificate validation error, it's because the client clock was wrong. Not because the certificate was expired, not because it's an actual attack. It's because like someone messed with their clock, or what we're trying to figure out also is why people are messing with their clock. Sometimes it's intentional to get to the next level of Candy Crush, I I hear. Sometimes it's malware. We hear that malware changes the clock sometimes because it can mess with antivirus software. Or it could just be, you know, an old device with a dying CMOS battery. We don't know why exactly, but it's overwhelming. So this is an obvious kind of problem area to try to fix. We have a clock interstitial in Chrome, and this rolled out around the time that we realized this was such an overwhelming problem. So what we really want is when Chrome notices that a certificate looks expired, and Chrome notices that the user's clock looks like it might not be wrong, it's great to kind of point them back onto the right track and suggest that maybe they want to fix their clock. So this is exactly what this special interstitial page does. It uses a heuristic to decide that, oh, this certificate looks expired, but the client's clock also looks not quite right, so I'm going to suggest to the user that, that they fix their clock, instead of showing them this scary generic message about their connection might not be secure, which they have no idea what to do with. So this is pretty cool. It helps a lot. But as I mentioned, it's based on a heuristic, and that heuristic, if you're wondering how it works, it's basically based around the build time, Chrome's build time. So Chrome looks at its own build time, looks at the system clock time, and if the system clock is outside a window around the build time, Chrome decides that the clock is probably wrong. But it's a heuristic. It has to be a little bit rough to avoid having false positives. And one thing that we've learned from our certificate report data set is that it catches 47% of the errors that it really should be catching. So that's pretty good. From this overwhelming number of false positive certificate validation errors that are due to client clock errors, we can cut them in half. So for half of those errors, we can show this friendly, helpful error message that is not scary and will help the user get back on the right track. But we are also investigating how to do better than this. So for example, we're looking at using a secure time service in Chrome to have a better approximation of when the client clock is correct. So that's work that we have underway this quarter. So as I mentioned, client clocks are overwhelming, the thing that emerges most prominently from this data set. But there are some other patterns that emerge, though in smaller numbers. So one thing we've noticed is that there is a set of software security products, antivirus, firewall, network security solutions, that intentionally man in the middle end users' HTTPS connections. And they generally do this by installing a root certificate in the client's trust store and then using that root certificate to man-in-the-middle connections. So you could argue that this is evil. You could argue that it has legitimate purposes. I think we have to accept that this is not going away anytime soon. And so we want, when a software security product is going to be doing this, we want them to be doing it the right way. And we notice that they're often doing it the wrong way, for example, just not installing the root certificate properly. So we noticed that at least 2% of every time that Chrome has a certificate validation error, it's due to some kind of misconfigured or buggy antivirus software. And when I say antivirus software, I mean a whole class of kind of security products that man in the middle HTTPS connections. I'm saying greater than 2% here because we don't have, in our analysis, we don't yet have a great way of detecting all instances of this problem automatically. So 2% is really a very conservative lower bound here. And it's also interesting to remember that 2% of hundreds of millions every month is still a really large absolute number and a large number of affected users. So one instance of this, as I mentioned, is the root cert just not being installed in the user's trust store. There's also just downright bugs. So for example, this is one common problem that we see. This is an example of an Avast root certificate. So Avast antivirus is man-in-the-middling this user's connection, and there's a problem with the root certificate. It's installed in the user's trust store correctly, but you'll notice that it's valid from 2000 to 2010. And this report came in a few months ago, and in this case, the client's clock was actually correct. So we have here an instance of Avast man-in-the-middling users with very expired root certificates. So we've actually been working with AWASP to fix this, and we hear that this is fixed in the latest version of AWASP. So that's great. So we've had some luck working with vendors trying to get bugs like this fixed. Fortunately, this was a pretty straightforward one to fix, but in some cases, it's like, the problem is like the network administrator just didn't install the certificate properly, so it's more a problem of unclear documentation or a lack of administrative tools or things like that that are a little less straightforward to fix. But wherever we can, we're working with vendors to get these problems fixed. One final pattern that's emerged from our data set. I said that a lot of this is just messiness in clients and networks, but you do have your standard class of blatant server misconfiguration problems, expired certificates, and things like that. One that is just immensely frustrating is 1.5% of reports are due to certificate names that are almost but not quite correct. And I'll give you some examples to explain what this means. But basically, this is an example where they set up HTTPS, they got the certificate, they did it so close, but just not quite there. So for example, the user requests foo.example.com and the certificate name is example.com. So someone was clearly trying really hard here, but just didn't quite get there. Another example, a wildcard certificate when the requested name is 2 levels of subdomain. So this is a really common misconception. A wildcard will only match one level of subdomain, not 2. And the grand finale is one that I hit the most often personally. You visit example.com and you get a certificate for www.example.com. This happens all the time, and to a developer, to someone who knows what's going on, you're like, okay, I see what's going on here, I'm just going to go to www instead. But to a user, they're not an average end user is not. This is going to be just as terrible as any other certificate validation error. So this is the most frustrating because it happens so often. And because it's it really is the closest of these so close kind of errors. So one thing we're experimenting with in Chrome, this hasn't hit Canary yet, but I think it's on track to hit this quarter, is just doing what the user wanted. So instead of hitting an interstitial where we went to a site and it says, this isn't the site you wanted to go to, but it's the www version of the site we wanted to go to, we're experimenting with, on a top-level navigation, just redirecting to the www version and printing a message in the developer console so that the developer will hopefully see the error, know what's going on, and know to fix it. But for the end user, they end up just going where they wanted to go. And we feel okay about this because in a lot of cases, Chrome already treats the www version of a site the same as the non-www version. So if you type example.com in the URL bar, Chrome feels just fine about redirecting you to www based on other heuristics. So we felt like this was a good compromise of user experience and strict certificate validation. And also, we're not, one thing to note here is that we're not actually bypassing the certificate error. We're just transparently redirecting to the version of the site that doesn't have the certificate error. So this is an example of what we're doing in Chrome to try to make HTTPS effective rather than scary, unnecessarily scary for users, so that we can honestly encourage every site to go to HTTPS without damaging the web. With some knowledge in mind about what's going wrong in the wild, we're making progress on these problems. And if we pop up one layer to the application layer, we are doing some things there to address some of the challenges that sites run into even after they get their certificate chains set up and correctly validating on all clients. So in the web platform, there are a number of things we can do, and I want to start with what we hear from developers as the most problematic in their applications when they move to HTTPS. And that's a problem called mixed content. So if you haven't heard this term before, the general idea is that when you load a page over HTTPS, if that page goes and loads some sub-resources over insecure HTTP, we call those sub-resources mixed content. And we tend to highlight this as a problem because it can compromise the security of the site as a whole when a script or an image is loaded over insecure HTTP. The problem is that it can be really hard on a large site to actually find and fix all instances of mixed content. We hear this from developers all the time. And if you end up with some mixed content slipping through on your site, Chrome does go to some length to try to notify the user that their security is compromised. So this is an instance of that UI I showed at the beginning of the talk, and I'm just highlighting some of the ways here that we are notifying the user about the presence of mixed content. So you can see we downgrade the lock icon, so you don't get a shiny green lock icon if you have mixed content. And we have these strings that try to tell the user and the developer what's going on, and that something's not right on this site. But as I mentioned, this sucks if you spend a bunch of time and money to go to HTTPS and then your users are seeing this kind of weird, scary state and they're not really getting the full benefits of HTTPS. So what we really want, what we heard from developers they wanted, was when migrating large sites, they want a way for their website to just say to the browser, I intend for all my content to be loaded over HTTPS. And if something slipped through that is being loaded over insecure HTTP, that was a mistake, and I don't want that to happen. So there's this recent addition, which we are standardizing and implementing, an addition to the web platform, where via an HTTP header, a site can basically say exactly that. So by sending this header, it's a value of the content security policy header, and content security policy is actually a much more general mechanism, but in this talk I'm just going to talk about this specific usage of it. But basically by sending this content security policy of upgrade insecure requests, the site is telling the browser, I intend for all my content to be loaded over HTTPS, and if you can't load it over HTTPS, just block it outright. So it's sort of a way for the browser to say, I don't want any mixed content. Everything should be available over HTTPS. So for, oh yeah. Strict transport security will not upgrade sub-resources that are cross-site. So for example, if you're loading images or if you are loading a jQuery from a CDN, upgrade insecure requests will upgrade those also. Strict transport security also won't, I believe, won't get rid of mixed content warnings, and there are very complicated reasons for that, which we can talk about it after if you want. Great question, though, thank you. So for example, if you have an image on your page and this is some, maybe you're a news site with hundreds of thousands of pages and you have some news article from 2009 where you have a mixed image that you forgot to upgrade when you moved to HTTPS. If you're sending the upgrade insecure requests header, Chrome will automatically upgrade it for you. And it'll be just as if you had typed HTTPS instead of HTTP. So this idea of sending an HTTP header to sort of enhance the security that you're getting out of HTTPS can be used to solve completely different problems as well. And one example of this is public key pinning. And I'm going to describe this mechanism and the problem that it solves, and then talk about what we're doing in Chrome to a project we have done recently to make this feature kind of more accessible to the masses, because it's previously been something that we advocated only for kind of the Googles and the Facebooks of the world. And I'll tell you why in a minute. So public key pinning, in a nutshell, is a tool that the web platform provides that mitigates the impact when a root CA is compromised. So it takes a little explanation. Let me unpack that a little bit. When you set up HTTPS on your site, you have a certificate, and that's basically a cryptographic key pair, kind of proving your identity, and its this proof is the form of a signature. So it's another signature on your public key, which itself has been signed by what we call root CA. And every browser and operating system, every phone in your pocket has a list of several hundred CAs that it trusts to kind of anchor what we call this certificate chain. So the problem that public key pinning is trying to solve is, suppose that another CA goes rogue or gets compromised and issues another certificate for example.com. So this second example.com certificate is what we call misissued. It was issued by a certificate authority that's kind of acting maliciously or not honestly. And what we would like is for the browser to be able to recognize this misissued certificate and say, hey, that's not the real example.com certificate. I can distinguish this certificate from the real one that was issued by the real example.com. So in other words, it's a form of attack surface reduction where we want to take all these hundreds of trusted root CAs and say, let's lock it down so that not any rogue or compromised CA can issue a certificate for any site. So public key pinning solves this via an HTTP header. That is a trust on first use mechanism delivered from the server to the browser with a description of what the site's certificate chain should look like. So there's this sort of complicated syntax I'm not going to describe in detail, but the mechanism is basically a way to describe what the certificate chain should look like, and then the browser remembers that description and will in future reject connections that don't match that description. So for example, one way to use this is to say, I always expect to issue my certificates from this root CA, and if you ever see a certificate issued from another root CA, something's gone wrong and you should not accept that certificate. Yeah. It's a hash of the the public key that you expect to appear somewhere in the site's certificate chain. Sorry, what was it? That you trust? Yeah, yeah. It can also be your leaf, so it can be your actual end entity certificate, but well, okay, this is a good segue actually. So, my next question is, what if you kind of get this wrong? And this is why we have previously only really recommended this mechanism for large sites with like operations and security teams that can make sure they know what they're doing. Because what if you pin to a leaf certificate and then you lose control of your keys for that leaf certificate? Or what if a client kind of builds a certificate chain in a different way than you expected? Because the chain that the server serves is not always the same as the chain that validates. And the public key pins that description of the certificate chain that the site expects has to match up to the one that the client actually builds while it's validating the certificate. Or what if there's just an operational error? Example.com is rolling out a new certificate and forgets to update some of its front-end servers, or is rolling out new pins and it doesn't quite do it right, etc. Well, what we call this situation is example.com bricking itself, where it's effectively performed a denial of service attack against itself in that it has pinned its certificate chain to some description that no longer matches the chain that clients are actually validating. And in practice, we hear it's really, really hard to get this right. So that's why we've previously kind of only recommended public key pinning for the Googles and the Facebooks of the world. People with security experts on staff, PKI experts on staff who can really be sure that they're not going to break themselves by rolling out public key pinning. But this talk is about HTTPS everywhere, for every site, every mom and pop shop. And so I want to mention a project that we've done recently in Chrome to try to make this a little bit more accessible to the mom and pop shops of the world. And that's a feature called public key pinning reporting. And this is actually in the spec, but Chrome is the first browser to implement this. Instead of serving the public key pins header, you can instead serve a report-only version of the header, where the browser will sort of treat this as advisory. It's sort of like saying, I'm in practice mode. This is what my certificate change should look like. But if it doesn't, if something should go wrong and you should see a certificate change for my site that doesn't match my description, then allow the connection to go through and just send me a report about it. So it's a way that a site can turn on public key pinning and kind of see what would happen, see if they are going to be DOSing themselves before they turn it on for real. And this is an example of what a report looks like. It has, the host name that was requested. It has some information about the pins, and notably, it has the served and the validated certificate chain. So as I mentioned a couple minutes ago, the chain that the server serves may not be the chain that the client actually uses to validate the certificate, and that's a really common cause of public key pinning bugs, and so that's why it's present in these reports. All right, so those are some of the things I wanted to talk about that the web platform can provide when migrating to HTTPS. In this last section of my talk, yeah. So there are several answers to that. So one answer is that the public key pins have a max age. So after a certain amount of time, the browser will forget. So, if you pin your keys for a month, you have to wait a month. So you have to start serving new pins. Wait a month before you rotate your certificate. You can also, in fact, you have to also pin a backup key. So you might pin like your CA and then another CA that you might use in case you want to switch. And you actually have to have backup pins to try to mitigate the impact of messing something up. So I just want to tell you about one more project that we have in the works. This is actually launching to beta today, I think. And it's sort of an acknowledgement that we're asking a lot of developers by pushing for HTTPS everywhere. It's not easy. I've told you about tools we're working on to make it easier, but it is a hard thing for developers to understand on average. And so what we're launching is a new panel in DevTools, a security panel whose sole purpose is to help developers find and fix HTTPS configuration problems. So this is going to beta. I want to show you a little bit of what it looks like, and but I do encourage you to go try it out. And it is in beta, so we are very eager for feedback. We know there are some bugs, but more reports can't hurt. So this is what the security panel looks like, and I'll just briefly tell you what's going on here. So the first thing you see is that we show the security properties of the main page load. So this sort of matches up with the lock icon, and it shows the developer if the site is in like the green, shiny, everything's good state, or this neutral state, which is sort of the page was loaded over HTTPS, but Chrome noticed some problems that stopped us from marking it fully secure, or the red state where something went really wrong, like we couldn't validate your certificate, everything is bad and horrible. So it kind of shows you the overall page load that matches up with the lock icon. The security panel is a place where we can communicate cleanly to developers about upcoming crypto deprecations. This is an ongoing problem when you set up HTTPS. It's not fire and forget. You have to keep up to date, keep your configuration up to date. And so in this example, the certificate chain has a SHA-1 signature, which is being slowly phased out. And so this is a place where we can communicate to developers about that. And finally, I talked a lot about mixed content. The security panel, we can actually highlight the security properties of sub-resources that have affected the lock icon or mixed content. And we can actually show the individual certificate chain details for every sub-resource on the page, which is something that we have never done in Chrome UI before. So as I mentioned, I just want to give one more plug. This is on beta, and feedback from real developers is really, really valuable. So you can feel free to email me with your thoughts, estark@chromium.org, or file a bug on the Chromium bug tracker. It'll get to the right people, and we would be thrilled to have your feedback. So I've talked about a lot of, as I said, a grab bag of projects today, but I promised you there would be a theme, and I think there is a theme, which is that that everyone says HTTPS everywhere. It's a good goal, but it really has to be high quality HTTPS. So that's why we're trying to understand what's going on from the client's point of view, understand why users may not actually be able to access HTTPS sites. We're trying to build tools into the web platform to make sure that developers are able to migrate their applications securely, and launching the new security panel and dev tools because we are asking a lot of developers by pushing for HTTPS everywhere, and we want to make this landscape comprehensible to them. All right, thank you very much for listening. I'm happy to answer any more questions. So I don't work on search myself, so I can't say anything too knowledgeable or official, but I know that this is something that Google search cares a lot about. And there was recently a rankings bump introduced for HTTPS. I'm not sure how big it is, but it's definitely, I know there are supposed to be ways that you can migrate to HTTPS without losing your search ranking. I wish I had a good, I can't think, I don't know if a good resource offhand to point to, but if you maybe come find me afterwards and give me your email address, I can ask some people to tell me what the resources are that that you can hand to your customers. Yeah. Yeah, to some extent we lump that into that antivirus and firewall software security category. I don't think I have any numbers offhand about like proxies as a category on its own, but certainly anything that relies on a root certificate installed on an end user device is problematic. Another little interesting tidbit in that category is if you've heard of Fiddler, which is a developer toolkit for debugging and inspecting TLS connections. One thing that we found from our data set is that it's actually really depressingly common for malware to use Fiddler to mess with HTTPS connections. So we end up seeing local proxies like Fiddler used to man in the middle connections in ways that end up with false positive HTTPS errors. Well, there are several checkboxes within Chrome. There is another checkbox I think that you get on install, which asks if you want to opt in to send general usage metrics to Google. And so a general metric like how many times do we show this page is reported as part of that program. The reason we had to do a separate opt-in for sending these certificate reports is that they contain much more sensitive information like the host name that the user is trying to visit, and certificate chains can even contain PII. So for example, if you install some antivirus software, the certificate chain can actually have like your email address or your license number in the root certificate. So the opt-in for certificate chains is kind of special, and that data is subject to much more intense privacy policies than more general usage metrics, such as just incrementing a counter every time we show the warning page. I don't know that I don't particularly want to comment on behalf of Google as a whole. I know that, I'm, there's a whole bunch of stuff in the deprecation pipeline. I'm actually not sure if TLS 1.0 is in it right now. But we do monitor, we do like monitor usage metrics very closely before deprecating things. And so, I would be surprised if we would just go turn off TLS 1.0 while it's while the internet still relies on it. But yeah, if you want to talk about it offline, I can tell you the people who would be the right people to talk to about that. Any other questions? All right, thank you so much.